Okay. Okay. Let's start to talk about. So today's agenda is about telemetry and GPS. We will go over the requirement for our telemetry system on the MS14, and we also go over like the different communication protocol that we are going to use on the telemetry system, and we'll go over the design, and also we'll talk about the GPS as well. So telemetry. We want to be able to listen to the system CAN bus, and our main goal is we want to broadcast the CAN bus to the chase car or the pit. So the strategy team can use those data to generate the strategy for the rest of the day. For example, we want to send like how much battery charge is in the battery, so the telemetry can figure out like what's the optimal speed for the car to drive. And we also want to log the CAN message to the cloud, just for like future like strategy analysis, or just like checking how the cars are doing. And we want the telemetry system to operate during both the FSGP and the ASC. We can go over like how the telemetry going to be used in the FSGP. So during the FSGP, when the cars are racing on track, we want to get the live data in terms of speed and ideally the GPS location from the car to the pit. And if you look at like the size of the FSGP circuit, it's pretty big. For like the Circuit of Americas, our last FSGP race is as wide as a 1.7 kilometer from one end to the other end. And the worst thing is that the pit is not in the center of the circuit and it's at the very edge of the circuit. And also some buildings like between the farther side corner and also to like the pit. So we could not raise up like a Wi-Fi router at the pit and then broadcast the signal all the way to the other end. However, if you look at like the 2021 FSGP, the condition is slightly better. So hopefully the pit will be around the center, and the distance between one end to the other end is only 1.3 kilometer. So it's like slightly closer than the previous FSGP, and it's an open field, so we shouldn't have any building or other stuff like blocking between the car and the pit. And the good thing is like both of the track has a pretty good LTE reception, so they're close to the city, so we shouldn't have any issue. And if you trying to figure out like what the telemetry going to work during the ASC, it's a slightly different condition. So during the ASC, the car will be moving on the road and it will be followed by a chase car. And if you look at the route, you can see a pretty good coverage most of the way. However, the route does go through the national park, and there could be some recession issues. So during the ASC, the more ideal choice would be just using Wi-Fi. And in terms of like picking which technology to use for the telemetry system, as you can see, we have like a bandwidth requirement of 500 kilobit per second because that's the maximum speed for the CAN bus. We could choose a technology with a slightly slower bandwidth, but in that case, then we will need to write extra code to the firmware to do filtering or compressing the CAN messages, which is not ideal. And we also ideally we want to have a solution that has a pretty good non-direct line of sight connection, because for example, during the ASC portion, during the FSGP portion, as I have mentioned, there might be some buildings between the pit and the car. So the connection might not be directly visible from the pit. And we also want the range to be as wide as 2 kilometers for the FHEP. And for the ASC portion, since the trace car will be closely following the solar car, the distance will be a lot closer. And we also want to keep the cost low. So that in terms of like cost of like purchasing like the equipment, and also in terms of like cost, if we decided to use LTE, we also want to limit the data costs. And the ultimate decision was just use Wi-Fi for the FHCP portion, and also for the ASC portion. So during the ASC, the car will be the chase car will be closely following the solar car. So we should get a pretty good Wi-Fi reception. And the good thing with the Wi-Fi is it has a pretty high bandwidth. So it shouldn't be an issue in terms of like just transmitting the CAN messages. And during the ASC portion, and also during the FHGP portion, we also want to use LTE. So the one benefit with the LTE is we don't have to set up multiple like towers to get a good LTE coverage, because we can just buy a SIM card and use a LTE dongle to get like get a data connection to the internet. However, the data rate of the LTE is a bit slower than the Wi-Fi. So however, it's still faster than the CAN bus, so it shouldn't cause any issues in terms of sending the data. And we also consider other communication protocols like LoRa. So for LoRa, it has a slightly lower radio frequency than Wi-Fi. That translates to a wider range, which can reach up to like 10 kilometers in theory. And you also have a much better non-direct line of sight performance than the Wi-Fi due to the lower frequency. However, the bandwidth is also much slower. So so it is around like 27 to 50 kilobit per second. So in that case, we might need to start through filtering the CAN messages. And we could also use GSM, the 2G network instead of LTE. It has a much slower speed, but the coverage is better. In terms of the overall design, we decided to use a Raspberry Pi as the center controller of the telemetry system. In that case, we can also run like Python script on the Raspberry Pi to do all sort of telemetry recording and also communicate with the server. And the Raspberry Pi, we use USB to CAN dongle to listen to the system CAN bus to sniff the battery status, the speed of the car, and the GPS signal. And we also can use a GPS head to get the GPS location of the car, and that will communicate with the Pi through the GPIO pins. And in terms of the internet connections, we can use LTE USB dongle to get a data connection to the LTE network. And we also have a Wi-Fi as a backup to communicate with the chase car. And then we can talk about the GPS. So GPS, as I've mentioned, we will use Raspberry Pi head that pretty much I get including like the antenna and also most of the GPS head also come with an LTE antenna and also LTE modem, so we can use that for the internet connection as well. And the GPS module taught to the Pi via a serial interface. And that means on the firmware side, we will just need to write some Python script to run on the Raspberry Pi to parse GPS location data. And also another benefit of talking to the GPS is we can get a very accurate like time and date information as well. And in terms of the overall performance of the GPS module, it has around like 3-meter accuracy, and it can turn on within 20 seconds. And you can find the location within 5 seconds if you already have the satellite data. However, if you just like boot up the GPS module from the code without any satellite data, it will take a bit longer. Okay, so is there any questions?
Pei, is there any work that needs to be done in terms of still speccing either of those modules?
I don't think so. Like we have really like we are able to run a script to get the GPS data, and I have really like tried to like just measure like, the LTE speed with that module, so we could just use the pi hat, and I'm not sure like if like Max have a different idea in terms of the telemetry system.
So then what's left to like test, I guess, when we get back on campus?
So do we have a location for where we want to like place the pi in the car? Because if we want to like we need to figure out position, figure out like a location to place a pi so we can get like a good Wi-Fi connection, right? Because if we put if we put a pi in certain location, it could be an issue.
Yeah. So yeah, we don't want any extruding antenna of any sort, and we shouldn't put it near anything with carbon fiber, I think. So
yeah,
probably
like
somewhere close to the windshield.
Yeah, I feel like I think the main thing is not really the carbon fiber, because like we can always just like cut off like piece of like
have
carbon
like a
fiber.
cutout.
It's more like the problem is, I feel like it's more like the solar panel, right? Because ideally we don't want to like place an antenna directly below the solar panel, but at the meantime, like solar panel pretty much like cover like all of the spotlight that's like pointing up for the GPS and also for the LTE.
Right.
Do you know if like Max is going to like spending more time on the telemetry, or?
I guess. I mean, we still have to decide where any of the antennas will go.
Okay.
Yeah, I guess that's what's left to do.
Yeah, for sure. And then certainly I also like just integrating with the firmware, right? So just like getting all the pieces like running.
Right. Okay, cool. Does anyone have any other questions? Maybe more about how the telemetry system is expected to work, or GPS? Cool. With that is our last knowledge share. So thanks, Pei. And have a good Saturday, everyone.
Bye. Good luck. Good luck for the school year.
You too. Thanks.